Hello everyone. In this video we're going to be solving an exponential equation. We have 2 to the power x plus 2/3 to the power x plus 3/4 to the power x equals 3, and we're going to be looking for x values. With these kinds of problems, there isn't a standard way to solve this. We can't log both sides because we don't really have anything for the log of a sum. So we can guess and check. You can always guess and check. So I'm pretty sure you found the answer by guess and check. But let's use what is called AM-GM inequality. AM-GM inequality works like this with three numbers. If you have A, B, C that are non-negative, the arithmetic mean, which is the average of these three numbers, is going to be always greater than or equal to the geometric mean of these numbers, which is the cube root of their product. And this can easily be proven if you set cube root of A equal to X, cube root of B equal to Y, and cube root of C equal to Z. By making the replacement and using the identity, you can prove that. I believe I've done this in another video. I can't remember exactly, but if I find, I'll share the link. So by using this identity, we can do the following. Since exponential expressions 2 to the x, 2/3 to the x, and 3/4 to the x are always positive, we can use this. So here's what we're going to do. 2 to the x plus 2/3 to the x plus 3/4 to the x. Add them up and divide by 3. That's going to give you the arithmetic mean is always going to be greater than or equal to the cube root of 2 to the x times 2/3 to the x times 3/4 to the x. Great. So AM-GM gives us the following. And we're going to go ahead and multiply both sides by 3. So we can come up with our original expression on the left-hand side. So multiply both sides by 3, and you get greater than or equal to 3 times the cube root of 2 to the x, 2/3 to the x, and 3/4 to the x. Now notice that they all have the same exponent. So we can go ahead and multiply the bases and then use a common exponent, right? So by using the property of exponents, a to the n, b to the n, c to the n, we can write it as a, b, c to the power n. Okay? Now, 3 cancels out. 2 times 2 equals 4. They also cancel out. So we end up with 1 inside the radical. But the 1 to the power x is also 1, and the cube root of 1 is 1. So the whole thing here becomes 1, so we don't really have to worry about it. We can just, ignore it. So now we get the following. 2 to the x plus 2/3 to the x plus 3/4 to the x is greater than or equal to 3. Great. So this is a really good result. But remember, our original equation said that they're equal to 3, or the sum is equal to 3, not greater than or equal to 3. So when does that happen? When you have the AM-GM inequality, when does A plus B plus C over 3 is equal to the cube root of ABC? When all the terms are equal, obviously, right? If you average xxx, divide by 3, or cube root x times x times x, you get the same thing. In both cases, you get x, one of the numbers. So this implies that 2 to the x equals 2/3 to the power x, which equals 3/4 to the power x. But when are these things all going to be equal? Obviously, when x is equal to 0. You can also approach it this way. Remember our original equation. And we said that each term have to be the same, and their sum is equal to 3. So each of these must be 1, which implies again that x equals 0. Make sense? Is that the only solution? Let's see. So far we got something good, but let's use some calculus, shall we? So here's what we're going to do. F of x can be written as 2 to the x plus 2/3 to the x. So I'm defining f of x to be this one. And then I'm going to differentiate f of x. F prime of x equals. Now, how do you differentiate a to the power x? This is one of the rules that you learn when you study differentiation. The derivative of an exponential function is actually the function itself multiplied by the natural log of the base. When the base is e, this just becomes a much easier formula because the derivative of e to the power x is itself, which is really cool. So in other words, e is the number that satisfies this. Okay, great. So let's go ahead and differentiate this function using the rule. So here's what we're going to do. 2 to the x multiplied by ln 2 plus 2/3 to the power x times ln 2/3 plus 3/4 to the x times ln 3/4. Great, easy, right? You just write the same thing and multiply by the ln of the base. Fairly simple. Okay, what am I going to do next? I want to look at the critical values for this function. So in other words, like maxima or minima. So let's go ahead and set the first derivative equal to 0 to find out if we can get a horizontal tangent, which indicates our function as a minimum or maximum. Make sense? Okay, but how do we manipulate this? Like solving this equation for x would be insane, right? But actually it's not that bad. So here's what we're going to do. Using properties of logs, we're going to simplify this. ln 2/3 can be written as ln 2 minus ln 3 from the rule, whatever that's called. And this one, same way, can be written as ln 3 minus ln 4. And that's equal to 0. Great, so ln 4 is ln 2 squared, so I can write it as 2 ln 2. So now, if you go ahead and distribute this, 2 to the power x ln 2 plus 2/3 to the power x ln 2 minus 2/3 to the power x ln 3 plus 3/4 to the power x times ln 3 minus, notice that there's a 2 here, 2 times 3/4 to the power x times ln 2, and the whole thing is equal to 0. It still looks bad, but we'll put it together. Let's go ahead and simplify this by putting the ln 2s and ln 3s together. So we have these two terms, and actually this one as well. So let's go ahead and put it together and factor out ln 2. If you factor out ln 2, we get 2 to the x plus 2/3 to the power x minus 2 times 3/4 to the power x. And then on the right hand side, if you put everything here on the right hand side, everything will be negated. So we're going to get ln 3 times 2/3 to the power x minus, not plus, this is a plus, so it's going to change, minus 3 to the 4th x. Now again, this equation is not very friendly, right? It's not easy to solve, but here's one thing that is super duper important here. Notice that ln 2 and ln 3 are irrational values, right? But these are rational. Why? Because we are raising them, well, not necessarily, but if you think about it, like if x is equal to an integer, they're going to be rational, right? Okay, so here's the thing. In order for this equation to work, you have to have 0 on both sides. Otherwise, ln 2 is going to be multiplied by a rational number, and then ln 3 is going to be multiplied by a rational number, but no rational power of 2 is going to equal a rational power of 3, because no integer power of 2 equals a integer power of 3. Anyways, that's a long story, so I want to keep it short. So this must be 0, and from here, we get something super nice again, and this implies x is equal to 0. So what do we have? We basically have a minimum at or maximum, right? How do you find out? So here's what I'm going to do. I'm going to take the limit as x approaches infinity. If you take the limit of f of x as x approaches infinity, you're going to find that it approaches infinity. But if you take the limit as x approaches negative infinity, you're going to find infinity again. So our function comes from infinity and goes to infinity. So it has to have a minimum at x equals 0. And that is the only solution. Let's go ahead and take a look at the graph and we'll just finish up. So here's the graph of our function intersecting y equals 3 at a single point, because that is the minimum value for our function at x equals 0. Therefore, x equals 0 is the only solution to this equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.